We're going to conclude section 8.5 by looking at one additional example of a vector application. Our problem says a cat is slowly pushing a 5-pound plant across the table with the intention of knocking it off the edge. The cat is pushing with a force of 1 pound. What is the total force being applied to the plant? Let's begin by thinking about the cat pushing the plant across the table. And let's write a vector to represent the movement of that plant. So if the plant begins here and the cat is pushing it across the table, the plant's going to move in that direction. So remember that we can write our vectors by looking at the magnitude and then multiplying by the cosine of the angle and the sine of the angle. The magnitude is the force with which the cat is pushing. So it says the cat is pushing with a force of 1 pound. All right, what is our angle? Well, if this is the direction that the cat is pushing the plant, then he's pushing it with an angle of 0 degrees. And so if I calculate this on my calculator, I'm going to do 1 times cosine 0, which gives me 1. And then I'm going to do 1 times sine 0, which gives me 0. And so this is the component form of the vector that shows what is happening when the cat pushes that plant across the table. Okay, and now there's another force that is also acting on that plant, and that is the force of gravity. The force of gravity is pushing down on the plant, and so it will produce a vector that looks like that. Now, the magnitude of that vector is equivalent to the weight of the plant, so 5 pounds. And what's our angle? Well, our angle goes from here all the way around to that line, so that's going to be 270 degrees. So I'm going to go to my calculator, and 5 times cosine 270 is going to give me 0. 5 times sine 270 is going to give me -5. And so now I have a component form for the vector associated with the gravitational force. Now, the question is asking us for the total force. So it would make sense that we would need to add these two vectors together to get the total force being applied to the plant. So I'm going to do the first components, the 0 and the 1, adding those together gives me 1. And then the vertical components, the -5 and the 0, adding those together gives me -5. And so my vector representation for the total force is going to be the vector 1, -5. Now, in order to actually find this force, we need to find the magnitude. And so we come back and we use our same formula for magnitude that we've used in the last couple of examples. We're going to have 1 squared, we're going to have -5 squared underneath the square root. So 1 plus 25. And so my total force is going to be the square root of 26. All right, which is roughly, if I go to my calculator, 5.1 pounds.